Ladies and gentlemen, time for the second panel of the Offshore dialogue named Monitoring the Ocean. It's a pleasure for me to welcome the host of the panel, Mr. Dr. Walter Kühnlein, solopreneur and advisor at Terra Blue. Hello and welcome, Walter.
Yeah, thank you very much.
Yeah, so let me ask you, why are you personally thrilled about that topic, about that panel now?
I think after you have listened to the first panel already, I think you get a feeling about how wide offshore industry is. And now we are really talking about monitoring the oceans, because I'm very happy, because I think I'm the first generation where we stop a tradition which we were using for thousands of years, and that is trial and error. Because nowadays we cannot afford it anymore to try things and then realize that does work or doesn't work. And I think in order to simulate things, in order to develop better things, you need to monitor the oceans, because you only can protect things which you know. If you don't know the oceans, you cannot protect them. And I think that's why I'm so thrilled, because this panel is now all about detecting the oceans, how to realize how are the oceans, what are the oceans. And I think that's really, really interesting.
Absolutely. I think it's a huge difference we can make here, yeah?
Yeah, absolutely.
Huge impact we have. So I'm thrilled about to listen to your panel now.
Okay, so thank you very much. So I hope that all of you have seen panel number 1. And this is a follow-up where we now say about monitoring the oceans, because as I just said, in order to see what is going on, in order how to protect the oceans, we need to monitor the oceans. We need to understand that. And it was, as Uli at the beginning of the panel 1 said, we don't know a lot of the oceans. Actually, we know more about the backside of the moon than of the oceans. And I think it's now really time that we work on that. And we have 5 flash talks, about 8 minutes each. And the topics are, first one is Avea Mariani. She's talking about the Green Deal of the EU in relation to offshore industry. Then Frank Adam is talking about floating multi-use platforms for offshore wind farm operations. Then Ethan Edson is talking about technologies for monitoring the microplastic in the oceans. And then we have a brand new topic, was just updated 1 hour ago. That is new strategies for autonomous new monitoring systems. And that is done by Stefan Marx. And Stefan Marx his company developed the equipment which was used for the ship of Boris Herrmann, who just sailed around the world. And I think one of the very, very few things which didn't break, that was actually the sensors which were on board. And then the last one is about the Ocean Technology Campus and the Digital Ocean Lab in Rostock. I think that's a very, very exciting topic. And Uwe Freiherr von Lucas is talking about that. And I think we should not really waste time. We should directly start. And maybe one comment that the Q&A session should be open. So there's a button at the bottom of your live stream, and there's a Q&A button, and just press it, and then you can ask questions, and then we will ask the questions after the 5 flash talks. So we would start immediately with the presentation of Avea Mariani.
The time left to save the planet's climate is very short.
能源问题也向人类生存发出了警告。
Climate change and the destruction of the ecosystems are an existential threat to civilization, says John Kerry. We are on track for an increase of 4 degrees by the end of the century. Emissions must fall by 7.6% every year. 2020 was a watershed. The US will rejoin Paris. The G20 will launch an international initiative for common rules for decarbonization. We are already exceeding tipping points. Our economies exceed the planetary boundaries, and we must revert course. No single state can stop this alone. We need to act together. Until now, however, we haven't succeeded. But today there is hope. There is the political will to act.
The European Green Deal is Europe's new growth strategy. We have to act now.
Climate neutral by 2050 means an industrial revolution. It can deliver climate neutrality and stronger natural carbon sinks. These are not only words. The Commission has released a 2021 work programme. The Green Deal covers all sectoral policies. It does really give the right price signals to the markets. An example, Vice President Timmermans confirmed that tax exemptions and subsidies on fossil fuels will be phased out. The Green Deal is highly specific. Let's look at transport briefly. The objective is minus 90% emissions. How do we get there? The Commission will boost multimodality, rail transport, will digitalize the industry, will focus on innovation. Offshore renewable is promoted by the EU, but it must take into account the carrying capacity of marine ecosystems. Today, we have a stronger horizon, the Framework Programme for Research and Innovation. I would strongly recommend that China works closely with the European Union for Horizon joint projects. China pledged CO2 neutrality, but we need to cut all greenhouse gas emissions. The Chinese leadership knows it. The Institute for Climate Change of Tsinghua University published a possible roadmap to climate neutrality for China. Common environmental and industry standards can help achieve a level playing field for trade agreements. The economic model is already shifting in reality. The economic rationale is changing. The linear economy is wasteful. This slide shows how we can transition from a linear to a circular economy with the right price signals. But how can we change the price of resources? One mechanism is the emission trading system. The EU is strengthening the ETS. China is taking similar steps. It would be time to start negotiating a global warming power tax. This is an industrial revolution. Old industries die, new industries rise. The main issue is energy. We need to transform the energy system. China is currently deploying ultra-high voltage transmission lines. With a global interconnected electricity grid, it will be possible to fully exploit the potential of renewables. This is another area where China and Europe can work together. Europe is also building a system of interconnects and a supergrid. For greater direct electrification, everyone will be linked and consumers will become prosumers. You can also have underground cables. Germany, where I live, is a good example. Now I show you a real project. The project I work on is called Agnes. Saipem in Italy has a plan to exploit integrated renewable energies in the Adriatic Sea. Trieste, in the north of Italy, wants to become a zero-emission circular port in the near future. It is an innovation hub. The port is integrated in the TEN, Trans-European Transport Networks. Those are intermodal corridors. Every year, Trieste is adding new rail lines. Today, 50% of containers traffic is by rail. The goal is to further reduce road trips by additional 50%. This is why the Port of Hamburg this year decided to invest in Trieste. The port of the future is powered by renewables, wind, photovoltaic, innovative technologies such as floating photovoltaic, agri-photovoltaics, floating wind. All this is consistent with the wind strategy of the European Union. But development policies will be in line with Paris and biodiversity. COP15 in May will drive change. The Trans-European Energy Infrastructure Regulation is being revised. Nature conservation and resource are part of life cycle assessment. Agnes will integrate all available renewable energy sources, offshore and nearshore wind farms, floating solar panels at sea, tidal energy, energy storage systems, and green hydrogen. The priority is to design waste-out products. Eco-design sets clear requirements for decommissioning. Innovation and research are key to recycling of wind turbines and for less wasteful products. There must be a clear date for full recyclability. Companies are exploring business models for reuse and waste prevention. KiteGen is an innovative solution. Green hydrogen will be produced by electrolyzers. Retrofitting gas pipelines before new builds must be a priority. Green hydrogen will power e-mobility in some coastal cities for public transportation. The first city is Ravenna. Hydrogen can power hard to decarbonize sectors such as steel production. Hydrogen can power shipbuilding. Fincantieri is interested and is working on fuel cells for big ships. Service and power packs are lined up at the port before the ship enters. Ships that need to refuel could do that in offshore hydrogen hubs. We have the technologies to power the ecological transition. 建设生态文明是困难的。
So thank you very much, Avea. I think that gives a good introduction and about all the challenges which we are facing, and some of them we will discuss here. And our next flash talk will be by Frank Adam, and he's talking about floating multi-use platforms. So Frank, the floor is yours.
Yes, thanks, Walter, for the introduction. We are seeing now the first page of my presentation. Sure, the title you know already. My name is Frank Adam, and on the left-hand side you see already a hybrid solution of an AC/DC platform, transformer platform, in combination with a hydrogen deck. This will be also a final picture of the presentation. But before, I would like to show you slide number 2. Please, the next slide. Yes, the motivation for this multi-use platform is quite simple. So as you know, from fixed offshore wind farms, there is especially a need when you're going far away from the coastline to maintain and also operate the offshore wind farms. And one of the first solutions to do that offshore was the Dantusk wind park, where a fixed offshore, let's say, hotel and offshore operation maintenance platform close to the transformer station was installed to maintain and operate the offshore wind park, because it's more cost competitive than to going there with CTVs, or it's cost competitive in comparison to a mothership approach or and transfer by helicopter. So meaning on the next slide, you see the motivation, especially we know fixed wind is working, fixed wind is a good solution, but especially those areas which are near shore and or in shallow or medium water depths are limited and different to sites and or areas which are in deep water and far away from the coastline. And this is presented here on this slide, meaning floating offshore wind can become a major pillar to manage the objectives of the EU Green Deal, and also to bring renewable energy to shore. But how to maintain those offshore wind farms, how to maintain those offshore floating wind farms. This is presented on the next slide. Here you can see one solution, which is a floating operation and maintenance hub. It's a floating operation maintenance topside, which considers already the income of potential offshore workers to have a good feeling by living and also working on this platform, because this was part of one EU-funded Horizon 2020 project to combine the living purpose with the operation maintenance purpose of such a platform, meaning the space and also the area of this platform is bigger than for typical offshore operation and maintenance platforms like Dantusk. And the whole design, the topside design here, is done also in that way that a modular approach was used to design the topside. Means it was done in that way that we designed and centered also a corner component which can be fabricated in a serial way, also to save costs later on and to follow also the multi-use approach, because to do and to use this platform only for operation maintenance is not only is not the only use case for this solution. And this will be presented on the next slide. You see here already a potential additional usage. As already mentioned, we are using this modular topside to find other usages for the space on those areas on the platform decks, meaning we are in the early stage to design a combination of a transformer platform with a hydrogen solution to produce hydrogen offshore and transfer it to shore via a pipeline, and or to have a combined solution with a typical export cable and or a pipeline solution for the hydrogen, as it was presented already before. And that's it from my side. The last slide is only the GCON slide. Happy to discuss with you later on.
So thank you very much, Frank. I think we got quite a good insight about how we can use such kind of platforms, and that you can not only use it for offshore wind, you also can use it for a lot of other things. So prior we come to the third flash talk, I would just remind you that we have our Q&A session open. So whenever you have a question, just type it in, and the questions will be moderated. So there will be somewhere in between you and that everybody can see that. So don't hesitate, don't be shy, just write whatever you think, and we will then start the discussion after the flash talk number 5. So I'm coming directly to the next flash talk, and that is given by Ethan Edson, and he's talking about a topic which I think all of us know about, all of us have seen pictures, and that's about plastic in the ocean. And he will now answer the question how to detect the plastic in the oceans. Even we all think we can see it immediately, but I think there's much more behind. So Ethan, the floor is yours.
Great, thank you. So my name is Ethan Edson. I'm the co-founder and chief technology officer at Ocean Diagnostics. We're a startup in British Columbia, Canada, and we're working on the issue of microplastics detection and monitoring in our oceans. You can go to the next slide. So plastic pollution, as Walter said, everyone probably knows about it at this point. About 8 million tons of plastic are entering our oceans every year, and this is set to potentially triple by the year 2025. As talked about in the first talk today, we live in a very linear economy where everything that we buy is consumed and then pretty much just discarded. And due to really low rates of recovery and recycling, unfortunately, a lot of this plastic ends up in the ocean. The issue with plastic is that it's a very hardy material. It doesn't degrade like metals or other materials. So once it gets in the marine environment, it stays there for a really long time. And UV radiation and other mechanical forces breaks this down into smaller bits called microplastics. You can go to the next slide. So microplastic pollution is probably what is most detrimental to ecosystems and to human health. Microplastics are defined as less than 5 millimeters in size. And these plastics are able to concentrate toxins, transport pathogens, and because of their small size and the fact that they're being ingested by the very base of our food chain, they can biomagnify up through many trophic levels. If you look at the literature, thousands of species have been documented ingesting these plastics, including us at the top of the food chain. Plastics can remain in the environment for many hundreds, if not 1,000 years. And we've only really been producing them commercially for about 60 years. So we really don't know how long these plastics are going to be in the marine environment and sort of the future problems that could exist as a result. Plastic is a very global, complex issue as well. Plastic that's discarded in one area of the ocean can break down into smaller pieces, and those can be transported globally. So it's not an issue, an environmental issue that stays in one place like many sort of terrestrial environments. Plastic pollution is very dynamic and moves around on global scales. And the biggest problem with plastic pollution, and especially microplastic pollution, is that it's very difficult to quantify these particles out at sea. Microplastics represent a small amount of the actual particulate in the ocean, but have a very detrimental effect. And the tools that are available to researchers and regulators right now to quantify these microplastics are not really fit for purpose, and a lot of them are very antiquated. So there's a real need for us to have enabling scalable technologies to quantify the effects of microplastics. You can go to the next slide. So at Ocean Diagnostics, we have sort of a three-phased approach to this. What we need first is to establish baselines. So we need to understand what are the levels of plastic that are out in the ocean? What is the size class of these plastics? How are they degrading? How are they moving around? Unfortunately, because of the sort of cost and antiquated technologies that we have right now, we don't have a lot of data to really support baselines. And that's an issue because as we move into the future and we start making changes upstream, we want to be able to monitor how those baselines are changing in the marine environment. So the second tier of our solution will be set up monitoring networks for microplastic pollution. And then as we create upstream solutions like banning certain types of microbeads, for instance, or getting better recycling infrastructure, or curtailing our need for plastics, we can monitor how those upstream effects are changing the downstream levels of plastic that are actually in the ocean. And then we believe this sort of data-driven solution is the way that we are going to be able to enable regulators and governments and society as a whole to reduce the amount of plastic that's going into the ocean. You can go to the next slide. So our DNA at Ocean Diagnostics, we were born out of marine scientists and engineers, and really our goal is to diagnose and protect the health of our oceans. And to do that, we've realized that we really need sort of enabling technologies that are low cost, that scale globally, so that we can quantify this issue. So our main mission is to develop these enabling technologies and offer them to sort of the academic and regulatory markets so that they can provide the data that they need to make societal change. Next slide. So we developed several different types of technologies. In the top left is our manual profiler. This is an instrument that we've been developing that will help us better understand the levels of plastics below the surface. And as we mentioned before, we're trying to make all of our equipment able to be deployed on many different platforms and deployable from small boats or even kayaks, so that we can enable researchers to go out and collect the data that they need. We're also working on sensors, which are probably the most relevant for eventual future monitoring networks. So we see the sensors that we're developing as really crucial to understanding how the levels of microplastics are changing over time. And with all of our technologies that we're working on, we're building them to be deployable from all different types of platforms, which I think fits in really nicely with some of the other talks today. You can go to the next slide. Another issue with microplastics is that the approaches for analyzing plastics back at the lab are very different depending on where in the world or which research lab you're conducting the experiment in. So researchers in one university might be using completely different collection and analysis methods than a group here in Canada. And as a result of that, it's really hard to compare studies around the world and understand the different sort of levels and ecosystem impacts of microplastics. So the second aspect of our business is to create a standardized, centralized laboratory using state-of-the-art instrumentation, novel isolation approaches, and a lot of sort of automated machine learning techniques to create a central lab where we can analyze microplastic samples in the same way. And we hope to set up several of these labs around the world so that samples can be sent in and analyzed exactly the same way. And for future monitoring, it's going to be really important that that analysis is done sort of in a cohesive manner in order for us to understand the levels of plastics in different areas. Next slide. So what is our vision for deploying the technologies we're working on at Ocean Diagnostics? Well, we really think that data is sort of the fundamental piece that is lacking right now for plastic pollution in the world oceans. And the reason for that is because, number one, the technologies are very difficult to deploy and expensive. It's very difficult for academic researchers or government researchers to get out and get ship time, and they have to spend quite a lot of money to get out on these research vessels. So our vision is to create enabling technologies that are really autonomous, and our idea is to deploy these on what we're calling platforms of opportunity. So rather than a researcher spending $10,000 a day to go out on a research vessel, let's tap into existing infrastructure. So cargo ships, cruise lines, ferries, sailing vessels, government infrastructure. And related to a lot of the talks today, we can talk about offshore wind and oil and gas platforms, or other sort of monitoring networks that have already been set up in the ocean. Let's create sensors for plastic pollution that we can strap into existing infrastructure, rather than having to sort of go out and on specific expeditions. And in that way, we can really create a lot of data that we need to better understand how plastics are affecting the ecosystems and how we can sort of manage them going forward. And as I mentioned before, for monitoring networks, we really need to get that baseline so we can implement upstream solutions and look at how microplastic pollution is changing downstream. And as a company, we hope to generate all of this data on these platforms and then sort of manage this data and provide it to governments and provide it to the people that need it to make societal change and reduce the amount of plastic that we're using. I can go to the last slide. Here's our information. Our website's www.oceandiagnostics.com. We're really excited to sort of tap into some of the existing infrastructure out there and scale our technologies to be able to better understand plastics. So, thank you.
So thank you very much for this very, very inspiring talk. And as you said, we need to measure it all over the world, not just on a few spots. We need to really measure it all over the world, and also in areas where maybe there's no traffic. And you also mentioned it a bit. Is it really sustainable if we hire a research ship to go somewhere in order to measure data? I think that might be not the best way. And that's why I'm very happy to have Stefan Marx here, and he was developing a sensor unit, a sensor box, which can measure on board of sailing boats. And actually, in order to convince the owner of a sailing boat maybe to use such a box, because of course people think that might need maintenance, that might disturb them, etc., etc. He was doing the best demonstration you can do, actually. He was putting this box on the sailing boat of Boris Herrmann, who was sailing around the world on this around the world race. And I think that is a fantastic thing that we can use, maybe utilize all the boats in future in order to measure the CO2, the oxygen in the water. I think that's very, very important. And Stefan, please continue. The floor is yours.
Yes, Walter, thank you very much. So everything is said, so I can stop. Okay. My name is Stefan Marx. I'm the CEO of Subsea in Kiel, Germany, and I would like to introduce an unexpected new way of monitoring the oceans. So next slide, please. Yes, you know this image. We all know the oceans make up most of the Earth. Many of our resources and markets can be found here. Let's just think of communication, mining, but also defense. Okay, next slide. Yeah, what do we actually know from the oceans, from most of our Earth? Well, all known dates are listed here. It is surface data only, and it's about 11 years old, but not much has changed. So what can we do? Next slide. Our approach was to find vehicles that would have to drive right here in the south of the Earth, around the southern hemisphere. And we identify only ocean racers come into question here. In 2006, we started development of the OceanPack monitoring systems for large vessels. We heard about 10,000 dollars per day. But in 2009, we were asked whether we can work on sailing boats with a partner from France. All companies said no, We said yes. And it worked perfectly. It becomes clear that this was an enormous challenge. Look at the image from the Boris Herrmann racing yacht. So it is hard to get data here. Please, the next slide. Yeah, here we have two photos of the ocean pack race to detect greenhouse gases on the left side, on the right side, a microplastic sampler. And we should be in contact with the other parties of this conference here. That looks very interesting. The ocean pack race can be detect greenhouse gases, CO2, but with the microplastic sampler, we are able to detect pollution around the world. It was specially developed for this purpose. With the help of investors, skippers, scientists, but the public, we were able to equip two racing yachts on the Vendée Globe just now. The Sea Explorer with Boris Berman, Yacht Club Monaco, and the new rest from Fabrice Amédée. Here, you can see the first data on the left side, which finished 3 days ago. So these data are raw data and not processed. There are no missing data and no peaks. The next slide, please. These data are raw, not processed. And the Max Planck Institute for Meteorology and the GEOMA in Kiel carry out the quality assessment. This means that climate models can now be calculated much better. And have a look on the left side. We have all the CO2 data from one expedition around the world in the south, and you see events like a sink for CO2 and a source of CO2 due to algae blooms, etc. On the right side, there are some older data from the Volvo Ocean Race equipped 2 years ago. And again, we have the first round the world data set. And we found data in the Antarctic. No one expected this. And of course in Asia, Europe, etc. The next slide, please. It is important to cooperate with other scientists, with other institutes. That is important for us. So here is an example from this morning. It was put to the public this morning from floats diving down subsurface and sending data later per satellite. So it is a combination of data, surface data from the race and subsurface data to give us the full picture of the ocean. The next slide, please. Yeah. As mentioned, we started in 2006 and it was a long, long way. So most of the time it was financed by ourselves. So we have more business units, not only the ocean pack, we are working in the business of oil and gas and batteries. So we have the possibilities to have a playground here to develop this technology. And you see we have expeditions with Arnold Fuchs or historic vessels. And it was a great story. Many expeditions were performed in the Arctic or Antarctic until now, success with the Vendée Globe. Please, the next slide. Why does it all work? Well, the biggest challenge is not only technology, it is of course, but also bringing together science, sport, industry, and the public. The technology has been around for a long time, but now the time was right to do it. That means we did it some years ago, but today it is a topic, a public topic. And our advantage is the proven technology taken from the subsea era because we are building AUV systems and technology for oil and gas. That means that the high sophisticated measuring device on board of the sailing vessel could withstand shock and vibration according and tested to military standard and AP70F from offshore oil and gas. And last day, unfortunately, our measuring device withstands the crash from Boris with his Fisher vessel without any peak or any failure of data. That's good for the data, not so good for him, but he has a 5th place and we are happy about this amazing event. Okay, the next slide. From this morning, the World Meteorological Organization just introduced that sailing boats can be a good platform to add more data into the common database. And Boris almost put it together again, a race that we must win. Okay, the last slide, please. Thank you for your attention. Okay, that was it.
So thank you very much, actually, for this very, very nice presentation. So there was actually a question which I wanted to ask, but you already answered it somehow. There was a rumor that you asked him to demonstrate how robust your sensors are, but I think that is just a rumor, right?
Yes.
Okay, so thank you very much. And when you develop such kind of things, and when you develop sensors or any kind of ocean-going instruments, then you have to test them. And I was once, it's a long time ago, on a ship where we tried to test something in 3,000 meter water depths, and we put it down in the water, and after 10 meters we realized we have a cable failure because water was running into the cable, and the entire mission, something like $50,000 a day, had to go back to the next harbor, and we had to repair it, etc., etc. So we lost a lot of money and, of course, the opportunity to test it. And that's why I'm very, very happy that our last talk, which is talking about the Ocean Technology Campus and the Digital Ocean Lab in Rostock, which is a facility where people can go there and test their instruments in limited water depths with limited work and very, very simple, actually. And this talk is given by Uwe Freiherr von Lucas. So Uwe, the floor is yours.
Yeah, thank you very much, Walter. So I will take the opportunity to give you some insight into the activities we have in Rostock. For those of you who are not familiar with the map, so we are north of Berlin, 200 kilometers more or less at the Baltic Sea, and eastward also 200 kilometers from Hamburg. And there we have been starting some 10 to 15 years ago to bundle our activities for subsea technologies. Next slide, please. So what we are going for is what we call a holistic approach for an innovation ecosystem. So the idea is to bring together the different parts that we need to be successful in this area. And if you look on the right side, our house of innovation, you see that we have different components, starting with education in the universities, but also other aspects for academy. We go into bundling resources for research. We have a digital ocean lab in the Baltic Sea we are working on. We also provide instruments for technology transfer. And of course, we also want to have the commercial activities in our campus area. And one aspect you see on the left side, this is a deep sea diving AUV with a lot of sensors, and there we also see it's a good collaboration of companies and Fraunhofer institutes and other partners. And I think for the challenges we already have heard about in the first presentation and the different questions we are faced, I think it's really necessary that we are faster in developing new technology, in really bringing ideas to market. And we see that the idea of such a campus, we see also in other regions, for example, the Cove in Halifax is more or less a blueprint of our activities. And I think it's a very good initiative, and we are happy that we have strong support from the different supporters, be it our local or regional government, also the federal government in Germany is supporting this. And this is, of course, an open approach, and so everyone is invited to join us. Next slide, please. So here you get an impression of the campus site here. It's located at the River Warnow. We have some new buildings directly at the marina. We have free space for everyone who's interested in joining us. And we will move with our institute to this area. It's the former fishery port of the fleet of the German Democratic Republic, and we want to make it a hotspot for subsea technology. We have a lot of our partners already settled there. Baltic divers who are offshore contractors. We have research organizations there, and also partners doing consulting for offshore security and safety. And so this is really a good place to grow. And where you see there is some maritime flavor. It's not so far to our beautiful beaches in Warnemünde. And so this is now under development. Next slide, please. So the idea is to have the different instruments combined there, and I will give you some insight into the activities that are currently performed in our campus site. So we have been launching interdisciplinary research group where we bundle 4 institutes of Fraunhofer Gesellschaft under the topic of smart ocean technology. There we have guys from computer science, from robotics, from subsea production, and from ceramics, so material science and sensorics together. They are now bundling their creativity and competencies for new challenges. The next is our Digital Ocean Lab, where we have a large test site under development around an available artificial reef, where we already have a platform, and we will create what we call yards dedicated to specific applications of subsea technology. It could be unexploded ordnance or subsea structures, cables, pipelines, and so on. All of those objects will be provided together with a good infrastructure for doing research and testing, and also demonstration of new technology. And this will be a very efficient way to test your new sensors, for example, and sensor and monitoring the ecosystem, the marine ecosystem on the one side, but also the technical systems on the other side is one very important part of this activity. In the third corner, you see an innovation platform, Sustainable Subsea Solutions. It's our concept to partner with international, especially European organizations similar to Fraunhofer, dedicated to applied research. And we want to build a strong network around the different oceans and use this as another important pillar to bring together ideas, capital applications, and so on. And I think this has a big potential to boost research, applied research in sensor technology and other technologies for subsea use. And a quite new development, we have just given a grant for starting a high-performance center where we bring together Fraunhofer competencies with the local guys from the University of Rostock and, for example, Leibniz Institute for Baltic Sea Research, where we put together all the ideas and also infrastructure we have and offer a single point of contact for innovation. Next slide, please. And the next one. So I think it's important not only to mention the decade in the different presentations, but also have it maybe as an end slide here as a starting point for the discussion. I think that even though we have electric propulsion for nearly all our vessels, our subsea vessels, and we already think about how to minimize the footprint, but I think it's really important to be even more specific and creative to really work on the concept of sustainable use of the oceans. And we have this decade now launched, and I think it's in our responsibility to provide the solutions we need, not to make the same mistakes that we have made in maybe exploiting resources on land. And so we are facing a lot of challenges, and we have to do this in an eco-friendly way. And this is also one very important question we are faced with in our local and regional activities, but I think this is also a global challenge, and we are happy to use the stage here and to get into discussion with the different stakeholders about how we can do this in increasing the sustainability of our economy. Thank you very much.
So thank you very much, Uwe. I think for this great talk, and I had the privilege to be there a few times in Rostock, and it's really unique what you are growing there. And if you still implement co-living, I will be there much more often even, I promise that actually. And it's a little bit like the movie Notting Hill. If Carmen would be still here, I think she would have asked now a total different question, because I think it must be clear for everybody why I'm so thrilled about this panel, because we were talking about so many things about how we monitor the oceans in order to protect the oceans. Because a lot of people, when we talk about that I'm coming from the marine field, then a lot of people say, oh, you are this guy who are polluting the oceans. But we also these guys who are trying to save the oceans, to do it much, much better actually. And I'm very happy that this 5 flash talks which we had, they were really flash talks. They were not only short, they were also flashing, I would say. So thank you very much for this excellent talks. So then let's directly start with the discussion. And Avea, I know you since quite some time, and I know that when it comes to saving the earth, and you are normally never really happy because you always want more and more. So one question, are you somehow satisfied with the Green Deal, and are you maybe even more impressed about what engineers, I know you're the only engineer in this round, that what engineers can do in order to save the world, in order to make the world more sustainable?
Well, what we can say is that this year has been a real watershed, as I was saying in the video, for the climate, at least in words. Because for the first time in history, since the 30 years that negotiations for climate negotiations have started, there have been a real consensus, a political consensus on the need to act. The European Green Deal is actually what is called the NDC, the nationally determined contributions of the European Union and all the 27 member states. What does it mean? It means that for the first time, we are serious about trying to get and achieve the goals and the objectives of Paris, and to try to stay below this 1.5 degrees, which is the new consensus which has been confirmed this year. The Green Deal in this sense is very promising. The problem is that it's only words at the moment. They are starting implementing it in legislation. The Germans, for instance, your government has started taking a step forward last year in December with the climate package, as the Klimagesetz, as you call it, and extending the pricing of carbon under the ETS to the two areas which are not covered by the ETS, which is heating and which is mobility. So yes, but we need to do it. We need to do what we are promising. That's the first question. Regarding engineering, and then I will cut it very short, it is what you've been doing. Professor Freiherr von Lucas Fraunhofer is a great institution in technology transfer and innovation globally, and is a leader, is a European leader. There are many European centers of competences. You need to do exactly what you're saying. You're talking about developing new materials, you're talking about developing new technologies and deploying the technologies that we already have, because we will need to do all we can now while trying to develop new emerging technologies or the breakthrough in paradigm shift that we need and we don't see inside, we don't have inside. So this is really what we need to try and act on.
Okay, so thank you very much. We have a lot of questions, as I can see. So the first one is to Ethan. What is the measuring principle of your in situ measurement device? So how do you detect the plastic?
Good question. Yeah, we use an optical method. So our sensors are sort of flow-through instruments. So we're sort of figuring out the best way to deploy them at the moment. But what's looking like the most likely option would be in sort of a flow-through system in a ship, where water is being taken in to make fresh water or cool an engine or something like that. We can sip off of that water, and in a sort of flow-through sensor, we can use optical detections to interrogate the particles that are coming through the flow stream and look for microplastic particles, as well as other organic particles and things like plankton. Using the imaging and sort of the other sensor technology that we have, we can sort of characterize all the particles, but at the end of the day, we're trying to get that concentration of microplastic particles per volume of water.
Okay, so thank you very much. It looks like that you motivated a lot of young people to grow their own startup. So there's the next question directly to you. How do you found your activities? That's normally a big issue always.
Yeah, that's a great question. I started actually doing microplastics research in university, and as I sort of alluded to in my talk, I found that the technologies that were available at the time were very antiquated, and they were sort of built for other oceanographic realms, basically. So we were using equipment that wasn't fit for purpose. So the startup really came out of a need for the technology that I wanted to do my research. And then the more that I developed it, the more I realized that there's a lot of people that could really use this equipment to better quantify plastic pollution. And we're still trying to figure out, exactly what that market is, but it's clear that we need to sort of scale technologies to be able to understand this very global problem.
Okay, thank you very much. So I think there's another question for Stefan. So what is the financial support which you got nationally and internationally in order to do this project?
Pardon?
Who was founding that? Who was founding that? Did you get national money? Did you get international money in order? Who was supporting you for doing this project?
Yeah, for the Wandy Glob and for Volvo Ocean Race, it is a little difficult because it's different to any other project. So no national founding for this. Wandy Glob is funded by sponsors and investors. So actually, the racing teams must put money on the desk by themselves. So we have to convince the sailors that if they have 20 kilograms more on board, they can win the race. And what is important for the sponsors, that they are part of a network for blue technologies and to help us to understand the ocean. So I think the most important thing is to come together and to have this network from the public, from the scientists, from companies, from investors. It's difficult to get money from the government or from Horizon 2020 projects, etc., because normally this is not the target of this projects and foundings, but there are some public foundations. And again, Schmidt Foundation, etc., and some others, they are interested into this, to go into this. This is a complete other market compared to the scientific community.
Okay, and did it also need a lot of efforts in order to convince Boris? Because as you said, this 20 kilograms which you have on board, it doesn't make the ship faster, and maybe he has to do some maintenance or some work with that, and he's already busy with the rest, winning the race. So was it very, very complicated to convince him? And then the second one is actually a lot of people are collecting data, and then they keep them by themselves. So I think that's also a first step, that you really make them public available and that you share that, right?
Yeah, absolutely. So in the past, we performed a number of expeditions, and the problem was to find institutes, because you can go to scientists, but they have to work, so they must do additional work. So who paid for this? But we found a combination of scientists, enthusiastic scientists from GEOMA, Max Planck, Ifremer, and other institutes to support this, because the scientists are the customers, the real customers of the data. For the question for Boris, Boris is the engineer, the perfect thinking man. He's very smart. He understands the advantage at once. But you are right, it was a long way, and to need more power, to need 20 kilogram on board. We have to convince them, and the point of view of sailors, of athletes, are completely different to our view, because normally they think we have a small device, we put it on board, and that is it. Yes, it is our job that it can operate unattended, and it will, but a little effort is required to do this, and this is why we make all this sea trials and expeditions, and so I'm happy to have the community to support sailors and scientists. And it was a long way, but with Boris it was perfect, and with Fabrice in France it's the same, so they understand what it is, and we can go.
Okay, thank you very much. We as the German Association for Marine Technology, we were also supporting him, and we were listening to his live video conferences. And I think you did a really great job, and especially as you showed the data earlier in your presentation, that you did not lose any data. And I think that's really, really brilliant. And I think that's the way we have to go for. And I think the next thing is, of course, we need to share the data. We cannot just keep the data as our own. And maybe we also have to change the culture, that also people who are collecting data get more appreciated for that. Because at the moment, only the people who do the analysis are getting the appreciation. And I have seen a lot of new expeditions where they want to collect the same data which has been already collected. And nothing is more sustainable than analyzing existing data. And we have so many existing data which have been not really and fully analyzed. And I think that's also very, very important that we go in that direction. And then I have another question to Avea. So what is the EU position on the negative carbon emission technology like NED, and what is this addressed in the Green Deal?
Well, first of all, I cannot speak about the European Union position I can just interpret the issues and the strategies. Of course, the problem with the removal, CCS, carbon sequestration, those technologies are unfortunately not mature enough at the moment to make sure that what is going to be their impact. So what we know for sure is that we are facing huge challenges in terms of decarbonizing the power system first. And that will mean already investing hugely in infrastructure, which means trying, if I understand well, to really summarize what is coming out over time. You first need to electrify as much as you can, direct electrification, which is the easiest and the most effective probably in terms of energy efficiency system. There are sectors you cannot electrify, and therefore the option is obviously to try to turn to hydrogen. Obviously, green hydrogen is preferred and is prioritized for clear reasons. And obviously there is a tension, and there is an ongoing political discussion between those who think that non-green hydrogen, such as blue hydrogen as it is called, coming from instance from gas, should be in the system. And this is a way to keep industry sectors in alive or in the system for a longer period of time. And this will also mean that some of the infrastructure that we have shouldn't be put in a condition of being become stranded assets in a relatively shorter time. Now, there is a political difference, but there is also a difference between states, even between the European Union members, among the members. Some of the states, I remember Spain, Luxembourg, Austria, I think, have taken a position about green hydrogen, and other states are saying, no, we should, for instance, in the taxonomy, consider blue hydrogen as renewable at the end of the day, although clearly this is not a decarbonized fuel. And we know that this is a very strong issue here in Germany, and a clear position as well from the German industry for a lot of reasons. So there will be certainly a position and a role for CCS sequestration, but once again, those are questions that will be answered by the technologies that are going to be mature at the time while we are progressing. And this is exactly answering your role before for science and technology. What we can know is that what we have to remember is that we have to try to avoid and minimize the mistakes that we've been doing in the first phase of our, so to say, in the last phase of our industrial civilization, which is the one which is based on fossil fuels. We are very aware of the mistakes, we know the consequences, and now we should try to minimize these impacts for as much as it is possible, because we live, and you teach me, under the laws of thermodynamics, so everything we do will be causing waste and waste of energy.
Okay, thank you very much. Yes, I know you're not speaking for the EU, but they listen to you, as I do also, actually. And so I think it's in a good way. And I have already a follow-up question for Frank, actually. How can hydrogen be stored and transported from the production side to the end user?
Yeah, it's a good question. In the end, there are different possibilities of a business case to do this transition from electricity to hydrogen. So you can do it offshore directly, store it also offshore, and the storaging can be done in reservoirs down at the sea. For example, at the moment, GECON is developing in a specific site in Ireland where an former gas field is decommissioned, and the reservoirs can be refilled with green hydrogen. This is, for example, one possibility to solve that. An alternative is not to store the hydrogen offshore and to have direct a pipeline from the offshore hydrogen platform to the shore. So there are different options available depending on the distance to shore and also depending on the business case you are focusing on. But the preferred solutions are storing the hydrogen at soil level or somewhere in the soil if there is a reservoir available, like for those old gas fields, and or transporting the hydrogen directly to shore.
Okay, thank you very much. There's a follow-up question about your floating design, which you just showed, and how can change this design in a way that offshore wind turbines are components to meet less maintenance, or can you use that also for maintenance, your unit?
The unit itself can't be used for maintenance, so it's not possible to disconnect it maybe from the mooring lines, float it over to the floating wind turbines and doing huge component maintenance. Therefore, different strategies are in the focus. One is, for example, to design a dynamic positioning vessel which can do huge component maintenance. This is under work of different designers at the moment. An alternative which is also focused from some floating developers, it's to disconnect the floaters, bring them back to shore and doing the maintenance, the huge component maintenance there. And for the, let's say, day-to-day maintenance work, there is an CTV or two CTVs available, and they are operating between the platform and the floaters and doing the day-to-day maintenance.
Okay, thank you very much. By the way, I like this red model in your background because 17 years ago, I did model tests with the grandparents of this model, actually. Yeah, so quite nice. So we have another question, and I think, Uwe, you really inspired the people, and it was quite clear that this question will come. How can I get a slot with your test field, and what are the costs?
Yeah, this is a good question. So at the moment, we are still in the erection phase of our test site. And the more specific, you can communicate to us your demands for testing, for demonstration, maybe also for training. We can fit those areas to your needs. And what is still under preparation is also the cost model, because even though we have really substantial investment that we can do with support of our government, we have to maintain it, and we have a lot of operational costs, and those costs have to be reimbursed by charging the so-called customers. And so I think it's really a very interesting phase now, where we want to go into detailed discussion with the end users of those different yards. And so feel free to contact Walter, the GMT, or me directly, and then we can check what is your need, and then find out how can we really support it with our infrastructure. We are just building in Rostock, and then we will, I think, find a fitting approach, and definitely it will be much more flexible and cheaper than testing your equipment with the offshore research vessel, where we have a lot of overheads, and where we need a lot of months in advance to prepare this. Even there, it's a challenge, but we want to have a much better offer for the companies for testing, demonstration, and training.
Okay, I have another follow-up question. Is it also possible to test, let me say, a cable for much longer time, so that you put it there and leave it there for years in order to see if there is water mitigating or something like that?
Yeah, so this is definitely something that we want to offer. Of course, we have to be in a very close dialogue with the governmental bodies, because we cannot do anything we want there. We need, of course, some allowance for those activities, but this is definitely a part of our concept, that we have long-term testing of materials, even of bigger structures and cables. And there we are also open for partnerships, because if maybe one of the participants here in this offshore dialogue would be a developer of a cable, and then we would be happy to have some 100 meter of the cable. He would be happy to have testing results. We would be happy if we could use sensors and autonomous vehicles using this as a playground. And so I think we will have win-and-win situations for both sides, and this is what we're looking for at the moment.
Yeah, sounds great. And as you said, I'm very happy to support you. So somebody comes in, then we can transfer it to you. Actually, by the way, did you already write an article in our German Association for Marine Technology related magazine? Or actually, we are a partner of them, Ship and Offshore?
We have been reporting, but I think it was last year, and so maybe it's time to give an update.
Yeah, and actually I can also ask the other people, if you have an interesting topic, send it to me, and we will be able to publish it there. I think that's also quite a good way in order to distribute the results, because I think we need to share things, otherwise it will not really work. And then maybe Frank and Uwe, another question. What monitoring needs can be tested on the testing site? So that means what kind of monitors can be tested? What is already there as an infrastructure? So Uwe or Frank, who wants to start?
So maybe I can start. We have a platform there, and what we do is manifold, as I said before. We do not only look into the environment, we also look into the technical structures, and there's also the link maybe to Frank and his activities. So we have a steel structure there, and one of my colleagues at Fraunhofer, they are providing a new way of censoring steel structures in a very efficient way, and we want to make this much more robust and without having any kind of maintenance, maybe integrating this technology in the next step into the coating of the structure. So there is ongoing research, and we are at the moment doing the concept, what are these sensors that we have around this platform, what kind of data we have to constantly monitor, and there probably we will end up with a typical solution. So we will have a CTD there, we will maybe go in turbidity, maybe have ADCP for currents, we'll have a BOA for wave measuring and so on. So this is at the moment in the layout phase. And then we will go into implementation. And what I want to stress is one aspect we have already not really covering here in the discussion of open data. I think it's really important to provide an infrastructure and a concept not only for our test site, but there we could maybe have a starting point for opening data sets, because if you just close up your data in a vault, it's really difficult to analyze your data if you cannot use neighboring data or older data. And I think there it's really important that we as a community make progress. And even though you open up your data, it's not that everything is for free, but that you have the awareness, that you have the information, what data is available, that you have a common understanding about quality. This is what Ethan said in the context of microplastics. If everyone uses different terminology and different qualities in his lab and resulting in different numbers in the data, then you cannot really work on this. I think there we have really a lot of work to do going into standards for data and open platforms combining data. I think this is one of the big challenges we are facing in the next 2 or 5 years.
So, Frank, you want to add something, or has everything said?
No.
Okay.
I think also the question was more with, for Mr. von Lucas, not for me.
Okay, it was written for both. So then maybe another combined question first to Ethan. So when we talk about plastic, so who should be financially responsible for recovering the plastic? And does it make sense to recover the plastic, or should we really do the first step that the plastic doesn't reach the oceans? Maybe Ethan, you answer first, and then maybe Avea, you just jump in after that.
Yeah, that's a really great question. It is a very global problem, so it's hard sometimes with plastics in the marine environment to point a finger to exactly who the plastic came from and how it was mismanaged. So what I think we really need to do is focus on upstream solutions, so making sure that plastic doesn't make it into the environment in the first place. We need better recycling infrastructure. We need better methods for getting rid of plastic. And we also need to make sure that we are limiting our use in the first place. So there's a lot of really exciting technologies that are coming out for developing, sustainable new products that are more biodegradable than plastics. And I'm hoping that some of those technologies can scale to the point where they will just, sort of be a good other material instead of plastic. So we need to focus on upstream things before we can recycle anything from the ocean. I think in the ocean, there are some types of plastics that are good for material recovery. So discarded fishing nets, which are very heavy and represent one material, they can be collected and repurposed into a new product. And that is a potential supply chain for recycled plastic from the ocean. But when you get down into the microplastics, it's extremely difficult to pick out all these microplastics and then combine them into a material that is going to be fit for use in a new product without degrading and going back into the environment again. So I don't really see microplastics or general plastic pollution as a good sort of recycling source. In terms of financing, that's a really interesting question. I think there needs to be some accountability from plastic manufacturers, of course, for the amount of plastic that's going into the environments. And I think governments really need to step up with recycling infrastructure and other infrastructure to sort of curtail the amount of plastic that we're using. And then, of course, societally, we need to just reduce the amount we're using as well.
Okay, thank you. So, Avea, you want to add something? I'm pretty sure you will.
Well, I guess I talk too much. I'm Italian. What can you do? Regarding measurability, I wanted to just to say that exactly the point of monitoring, you can't control, you can't manage what you don't measure. And you were talking, Ethan, and also the professor Uwe, about the planetary boundaries. And plastic is something that we do not measure at the moment. What is the level of tolerance of the planetary boundary for the oceans in terms of how much plastic we inject? And it's about 12 million tons a year. Going to recycling, we use recycling in a societal way, in a wrong way, because we're not actually recycling the most of the plastic that we do actually produce. We're just recovering and turning it into something else. And that is a major issue. And on the top of it, even countries like you, like Germany, will always maintain that we were leaders in recycling. We're not, because we've been not able for many decades to treat the plastic waste that we've been producing. And that is why we were exporting it. We were exporting it to China, for instance. And when in 2018, there was a ban, partial and now total, and the European Union has decided correctly to avoid and to ban the export from Europe of recovered materials for waste material for recovery. That means that our industries are not capable of utilizing the waste that we produce as a society. So Ethan is right. The first action is to cut, which means that some of the products will have not to be reproduced at all, because we have also to be very clear. Not everything we do with fossil is replaceable nowadays or will ever be replaceable, because the resources that we have on this planet do not simply allow for it. You're talking about biodegradable plastics, very correct, but still, are we going to, where do we, for instance, there is an Italian technology, an important company, which comes from the tradition of green chemistry, and they use basically plant-based material, raw material for recycling, for biodegradable plastics. But how do we supply the materials, the raw materials that we need for replacing the same amounts that we're using today? This is not going to be possible. So cutting some of the usages, designing for recyclability, recycling for making materials to stay in the system as long as possible. Those are the fundamental principles cycling the circular economy. The European Union, to go back to you, has started a plastic strategy, which is based on this principle, and this is a step forward. But this year, think of how much we injected in the system with this, with the COVID-related materials, because plastics is very versatile. So, and then there is the innovation for chemical recycling, which is probably going to offer some solutions, but we need a lot of injection in terms of funding for research and development.
So thank you very much. I fully agree on that. I started my career some 35 years ago by collecting oil, and we had once a job where we were sailing out and we were collecting 20 tons of oil from the ocean, and our engines were burning something like 50 tons. So that is also not really sustainable. So I think, as you said, we really need to avoid it and recycle it prior it comes to the ocean. Then, Stefan, I have a question for you. And a lot of sailboat owners were calling us, and they want to have a 25-kilogram box from you. So are you planning to produce it in a mass series? And what would it cost, actually? Or you get it or they get it for free? Because you get the data.
No, we are a company. We produce products and we sell products. That is it. Yes, it is a small sales production, and you know the community, the oceanographic community is small. So mass production is 10, 20, 30 units per year, something like this. Yes, you can contact us. We have a sales page for other countries, and cost depends on the equipment of sensors. So the most important and most expensive components are the sensors, starting from 30,000 euros up to whatever. But keep in mind that for sailing boats, it depends on the space and what is needed and what is your goal to have this on board. If you are related to scientific communities with scientists, so let's first discuss what is the goal and what is the resolution for specific physical or chemical or biological parameters. And then we select the right sensors or analyzers. For example, it's not only CO2, it's not only the microplastic sampling, it is algae, dissolved oxygen, salinity, temperature, of course, in the seawater, etc. Yeah, so having the idea about the ship, that is the first step. Then we have to design the system, starting with very small systems, especially for racers, that is dedicated to racers. For larger vessels with more space, so we have standardized components and systems, the so-called cube systems, so like a size, and this makes more sense in terms for maintenance and service.
Okay, maybe you are as the first one. We have a last question to all of you. Please, just 1 or 2 sentences. So, what is the benefit for the society if we are monitoring all this data in the ocean? Just 1 or 2 sentences, each of you, please. Stefan, you want to sell it, so you should start maybe.
Okay. One sentence is that normally monitoring is completely useless. If there's no waste in the water, we don't have to monitor it. So we know that there's waste, and the most important thing is recycling and stop the injection. I completely agree with you. But to monitor, to bring data to the public, it is important to show what happened with the money, with the text of the people, and bringing together the public, the decision makers, to have the right decisions for the future.
Okay, so someone else want to join? Yes, this were 3 sentences. So Uwe, Area, and Frank. Ethan also, then everybody, okay.
Yeah. So I think all the activities we do in the oceans have an impact. And I think it's important to have a good objective basis. What are those impacts? And for this, it's crucial to have a lot of data to value those impacts. And so we need monitoring concepts and cheap and robust sensors.
So Ethan and Frank, and then Area.
Great. Yeah, just to echo, I think what the take-home message from my talk is that with plastic pollution, we have sort of land-based sources that are completely anthropogenic that are coming into the ocean. So in order for us to better understand the current levels, we need to measure the baselines. And then as we make upstream changes, we really need to have monitoring in place so that we can evaluate if these upstream changes are making a difference in the marine environment or not. And if we don't have that monitoring in place, there's no way for us to validate whether the things that we're doing on land are having any effect for us moving in the right direction to meet, sustainable development goals.
Okay, thank you very much, Ethan. So, Frank?
Yes, I tried also in 1 or 2 sentences. So from my understanding for the society, it's quite important to communicate also to the society only things which you can deal with. So meaning the better the databases is, the better the actions can be.
Okay, Arvia?
I would like to dream, and I would like to talk about what you were saying also, Uwe, but also Frank and Ethan, about the importance of data. Nowadays, we are developing new operational modes and new technologies and new business models based on data. And in some places or in some industries, such as agriculture, data will be increasing the effectiveness, reducing the quantity, for instance, of water that we are using, because we will do agricultural precision agriculture. And I would say that real-time exchange of data, and this is a problem in Europe because we care a lot for privacy, and this is very important. This is protecting us. This is really protecting us. And this is allowing that governments keep their control over, for instance, the platforms. We don't want to live in a place, in a world where private companies own our data and use them as oil, because this is the oil tomorrow. But what we need to do, even in Europe, is to be able to harness the potential of this data, to go, for instance, and check exactly what the marine life is doing. Is it thriving? We have an offshore plant, for instance, or we got floating photovoltaic. What is happening in terms of temperature downwards in the water? Is the water affected? Is the local life affected? And to intervene and react. That is very, very important. And nowadays we've got this potential and we need to use it.
So thank you very much. I think these were perfect closing remarks. And so I would like to thank all of you. I think it was a fascinating panel. And I think Carmen fully understands why I was thrilled, because I think we covered a lot. And thank you very much. It was a great pleasure working with you. See you next time. Bye.
Thank you to Walter for this really great moderation of the panel. Thank you very much.
Yeah.
Thank you, Walter.
Thank you very much.